All right, number 19.
Lonnie Alvarez.
I'm back.
Front office.
So for this one, I'm assuming this is a calculus one. So I'm going to look. First of all, it is continuous, so it's not B. The derivative is 3x squared, and the derivative is 1. So when you plug in, the derivative is not it. It's not D, because the derivative at 0 doesn't exist there. F has a relative minimum. That's not true. That's what the graph looks like. No. The derivative is greater than 0 for everywhere but at 0. That part is true. So it's positive. It's positive. Right at 0, it actually doesn't exist. So the answer is E. All right, turn the page. 24. Just go with it. Let me rearrange the book here so I can figure this out. So f at x equals x squared subtract 2x subtract 1 to the 2/3. Take the derivative. These are the easy questions we really want to get right. So we multiply 2/3. Remember there's a hook. Subtract 1, 2 take away 3 is negative 1/3. Then the hook at the end. Then plug in 0. So if I plug in 0, I end up with negative 1. And the cube root of negative 1 is negative 1. So it's a negative, so that's negative 2/3. And that's negative 2. I think a positive, right? 4/3 is what I get. A, 25. The derivative of 2 to the x. Copy it and the hook. Answer C. It's not a hook, it's part of the formula. You copy, the hook is 1, copy, but it needs, because the base is not E, we write down ln whatever the base is at the end of it. X cubed plus 12x minus 24. And it talks about increasing and decreasing. So I know I'm going to have to take the derivative of this. I'm going to make it equal to 0, and I'm going to solve it. So I'm going to subtract 12, divide by 3. I get negative 4. I get no answer there. So for me, I have nothing here at all. So no matter what number I plug in here, the answer is always positive. So for everything, this whole thing is increasing. So it's increasing everywhere for all of x. The answer is C. There is no answer. You can't take the square of a negative number. Here we go. What number was that? That was actually 27. I'm going with it. Number 30. We have x equals 3. We have y equals the square root of x. So I'm going to graph this. Y equals the square root of x. You should be able to graph that. 3. And it's enclosed there. No spaces, right? Revolved around the x-axis. So I'm going to integrate from 0 to 3, the square root of x, and it's pi r squared. The radius is top subtract bottom. There's only one. There's no space here. One circle. So the square root and x, they cross out, and then they integrate that. I get add 1 to the exponent and divide, and that's from 0 to 3. And then I'm going to plug in. So that's 9. 3 squared is 9. So that's 9 over 2. Subtract 0. So I get 9 pi over 2. Answer is C. 31. We have f at x equaling E. Now, I already see what I'm going to do here. That 3 in front goes to the exponent. So that's going to be 2 and 3. That's going to be x to the 6th. And I know that e and ln cross out, so it's just x to the 6th. So that means the derivative of this is 6x to the 5th. And that means it's e. They made it feel like it's complicated, but it was using some logarithm properties. simplifying it, then take the derivative, and it's simple. 32. We're going to integrate from 0 to root 3. You know you should be doing these first, right, by yourself. This looks like arc sine. So if that is arc sine, then a is the square root of 4, u is the square root of x squared, and the derivative of u, the hook, is 1, which is perfect. And then the formula. So there's no 1 over a for arc sine. So it is just, oops, not a fraction line anymore. It is just arc sine u over a, which is x over 2, and that's from 0 to root 3. So if I plug in root 3, we have arc sine root 3 over 2 minus arc sine 0. And then we have to answer it. Now there's no answer there. We got to know our unit circle. So let's figure this out. So the y coordinate is root 3 over 2. Sine goes with the y. That means the x coordinate's 1/2. That is a 60-degree reference angle. That point goes with pi over 3 because I'm looking for the angle. Arc sine is 0. When the y coordinate is 0, the x is 1. That goes with 0 for an angle. So it's just pi over 3 take away 0. So the answer is pi over 3. The answer matches with A. 34. It says the top of a 25-foot ladder sliding down a wall. Here it is. It's sliding down a wall at a constant rate of 3 feet per minute. When the top of the ladder is 7 feet from the ground, this is 7, what is the rate of change of the distance between the bottom of the ladder and the wall? Right here. So first of all, I'm going to write down, well, a squared plus b squared equals c squared. That's what's connecting. The 25 will never change. It's a constant, but this one is going to change. So I'm going to take the derivative of this and then plug in. So that's 2a dA by dt, and that's 2b dB by dt. So take the derivative with the hook, take the derivative with the hook. So I know that this here is 7, and that it's falling down at a rate of 3 feet per minute. That's going to be -3 because it's falling down. Then I need to figure out B. That's this side right here. So if you solve that, I'm like 100% convinced that number is going to be 24. So you can see for yourself if that answer is true or not. But using the Pythagorean theorem and solving this, I think the answer is 24. It's a triplet, what they call a Pythagorean triplet. And this is what I'm looking for. This rate right here is what I'm looking for. And the derivative of 25 squared, the derivative of any constant is 0. And now this is what I'm going to solve for. So I have my rate that I'm looking for. I'm going to add this to the other side. So it's 6 times 7. I'm going to add that. And then on the other side, I'm going to divide by this. And notice I'm not simplifying it too bad because 24 into 42, 6, right, goes into both. So that's this. I get 7 over 8. And the answer is D. I know the answer is not negative because the bottom of the ladder is increasing. So as it falls down, this is increasing. So it can't be a negative rate. So I know A and B are wrong. And then I got the answer. Good. 37. You're given f is differentiable, then the derivative of f is which one? So we're looking for the derivative formula, right? And so I really like the first one. That's a good derivative formula. I want to see if there's another one that's good or if that's it. So that is it right there. This is like y2 minus y1 and so on. That's the limit definition of it. For number 2, that can also work because that's the alternate definition of it. So I like number 2 as well. I like all of them. I'm going to say E. All right, 38. That kind of question where you have to think, and hesitate That's the kind of one you wait to the end, do your best, and go for it. But that's not one that needs to like make you hesitate and not get to other questions. So the second derivative is there. Which of the following could be f at x? So I'm going to do the antiderivative of what I see. So I have 2x minus cosine x. The antiderivative of that, antiderivative of cosine is just sine, so it's a negative sign. Then I'm going to do it again. So I'm going to add 1 to the exponent and divide. The antiderivative of sine is negative cosine. So a negative and a negative is plus. And then it would have to be some constant. So which answer matches this? Oh. So when you do the antiderivative here and do it, you would have an x and then another constant right here. So the only one that could match that, anyways, is B. Done. 41. This one, the derivative and the integration, you're going to look at it first, right? Do your best. What do you think? Then watch it. Try your best. These cross out, right? And this just plugs in for x, so it's cosine 2 pi x, and that's it. The answer is D. It's just a substitution question. 44. What's the minimum value here? How do I find that? Well, minimum means take the derivative. I'm going to use the product rule. The first times the derivative of the second plus the second times the derivative of the first. Wait a second. The first times the derivative of the second times the derivative of the first, which is just 1. Make it equal to 0. So x times 1 over x is just 1. This is ln x. So ln x equaling negative 1. It's impossible for a logarithm. Well, ln x equaling negative 1. So write this as a, it's possible. Write this exponentially. That's the same as 1 over e. So that's the only critical number, is at 1 over e. Then when I plug 1 over e in to find that minimum value, this is in front, so that's just negative 1 over e, and ln e is just 1, so I get negative 1 over e as an answer. Answer C. Done. Is that the last one? No! That was the last one. Mr. G Math, over and out. Until next time. Great job doing your homework.